All right, so let's take a look at how we can figure out the number of solutions that a system has before we even graph it. Right? This doesn't tell us what the solutions are, but it tells us how many solutions we can expect. So when we think back to the possible number of solutions, right, remember there was 3 choices. We could have one solution. That was when our lines were just intersecting lines, right? They met once. We could have no solution. So that's when we had parallel lines that didn't meet. And the last option was those coincident lines where we have an infinite number of solutions because the lines are overlapping. So to look at this one solution case, right, we have 2 lines. These 2 lines have to have different slopes. Right? For 2 lines to intersect, they can't have the same rate of change or they'd be parallel. And in this case, it doesn't actually matter in terms of the y-intercepts. If we notice in this case, right, they have different y-intercepts. But I could look at a graph that maybe looks something like this, where they have different slopes. They intersect once, but that intersection points happen to be their y-intercept. Right, so they can either have different or the same y-intercepts. Either case, as soon as they have different slopes, these 2 lines can only meet once. Looking at our next situation, when we have no solution, right, these means we have 2 parallel lines. Well, we know from RF3 and 5 and 6 and 7 that when we have the same slope is when we end up with parallel lines. So to have no solution, our lines have to be parallel. We have to have the same slope. But for them to not meet at all, they can't have the same y-intercept, or else that would be a point in common. So they have to have different y-intercepts. Now, when we look at the last case, infinite solutions, right, these lines have the same slope because they're technically parallel lines, but they're parallel lines that are overlapping. They're parallel lines that are the same line. So they're going to have the same y-intercept. So if we have our equations in slope-intercept form, right, where we can quickly see the slope and the y-intercept, this can help us figure out how many solutions we have. Right, so in this case, different slope, as soon as our m value, right, in y equals mx plus b, y equals mx plus b, as soon as our m value is different, then we already know that we have only one solution. But we have exactly one solution. We don't have any more and we don't have any fewer. As soon as we see that our slopes are the same, then we can look at that y-intercept. We can say, well, is the y-intercept different? Well, then we're actually 2 separate lines, so they'll never meet. Is our y-intercept the same? That means we actually have the same equation twice, right? It might look a little different, and we'll see what that looks like. So let's look at these 3 examples at the bottom. We're going to convert each into slope-intercept form so that we can quickly identify that slope and that y-intercept. So let's look at the first set here. So I'll just cut these off. So for this first one, 3x minus 6y equals 10. Again, we want to isolate y. I'm going to pull the 6y to the other side because I like to work with positives, especially on my coefficients of y that I know I'm going to have to get rid of. At the same time, to keep life simple, I'm going to bring the 10 to the left side. Right? I'm taking my 10, bringing it over here, and I'm taking my 6 and bringing it over here. Now to get just y, I'm dividing everything by 6. I get 3/6 for x, which we know that that's 1/2. I get 10/6 for my y-intercept. And so to tidy that up a bit, oh, I lost my x. Right, 3/6, getting rid of that common factor of 3 means I have a slope of 1/2. 10/6, getting rid of that common factor of 2 means I have 5/3. So there's my first equation. Let's look at our second one now. So our second equation, we have 9x minus 18y equals 3. I'm going to do the same idea here. 9x, I'm going to bring the 3 to the left side. That's going to become negative, while I also bring the 18y to the right side so that that can become positive. I'm now dividing everything by 18, right? Get that y by itself. I have 9 over 18 as my slope in front of x, minus 3 over 18 as my y-intercept. And this is why we want to simplify those fractions. Because 9 over 18 and 1 over 6, or 1 over 2, or even 3 over 6 don't look exactly the same. But we know that 9 over 18 can be reduced to 1/2, right? Dividing the top by 9 and the bottom by 9. 3 over 18, they have a common factor of 3. That gives us 1/6, right? 3 divided by 3 is 1. 18 divided by 3 is 6. So what we notice, and why it's super important to simplify our fractions, is that these two things have the same slope. So again, we reference our chart. Same slope. I'm now at one of two options, either no solutions or infinitely many solutions. So then we look to our y-intercept. Again, why it's important to simplify those fractions, because we notice that these two are not the same fraction. So that tells us that these two lines are parallel, right? They have the same slope. They have different y-intercepts. Therefore, there's no solution. If I were to graph these, they would never meet. And even if I were to zoom out forever and ever and ever on my graph, they still would not meet. Let's move to the second one. 3x, I'm going to bring the 8 to the left side, bring the y to the right side, and now the y is already isolated. So that one was pretty easy. Nothing to reduce here, nothing to simplify. Let's look at the next one. I'm going to have 6x. And again, I'm going to swap places because I want that y to be by itself and ideally positive. But I also want to get everything from the other side, right? That constant term over with the x. I'm going to divide everything by 2. 3x minus 8 is equal to y. And when you look at that, even though these two equations look different, they're actually exactly the same. Once we reduce any common factors, these are both equal to 3x minus 8 in terms of y. So these are the same line. Okay, they're the same equation, they have the same slope, they have the same y-intercept. So they intersect an infinite number of times. They have infinite solutions. Every single point along this line is a solution. For whatever x, y that satisfies one, it has to satisfy the other because it's the same equation. Moving on to the last one. 4x minus 9 equals 3y. Right? Again, I'm bringing the y to the right side. And to save myself a step, at the same time, I'm bringing the 9 to the left side. I'm reducing, right? I'm now dividing by that common factor of 3 to every single term. I get 4/3 x for my slope. I get negative 3 when I reduce that 9/3 equals y. Again, we can't figure out anything until we can compare both equations, so converting that second equation. 2x minus 15 is 5y. Dividing everything by 5, I get 2/5 x. Right, divide that by 5. Minus 3 equals y. Right, divide that by 5. So in this case, we notice they have different slopes. Right, one slope is 4/3. One slope is 2/5. Again, our chart tells us that that means they have to only intersect once. Right? They're lines with different slopes. They have to meet at some point, but only one point because they're straight lines. And in this case, we actually know the solution right off the bat because our y-intercepts are the same. right? If they have the same y-intercept, the y-intercept is just a point. And if it's the same between the two, then that's the point they share. So they have one solution, and technically without even solving, we know that it's at 0, -3, right? Because they have that shared y-intercept. That has to be their point of intersection. So let's go through one more example. You're given an equation. Let's write another linear equation that will form a system, a linear system with one solution, with no solutions, and with infinite solutions. So to deal with that, first thing is I want my original equation to be in slope-intercept form. Because again, the number of solutions always comes down to, is the slope the same or different? Is the y-intercept the same or different? So I'm going to bring the 2x to the right side. And I see that my first equation looks like y equals 2x plus 4. So I have a slope of 2, and I have a y-intercept of +4. Well, to have one solution, I need a different slope. So now it's up to me. I get to choose any slope, and as long as it's different, these will have to have one solution. So I could say y equals 3x plus 4, right? It could have the same y-intercept. I could also go way off the deep end. I could go y equals -1/2 x plus 17/3, right? Making up anything. As long as that slope is different, that's the only deciding factor, right? As long as the slope is different, they're only going to meet exactly one time. All right, no solution. So again, for these, we needed same slope, right? We needed parallel lines. Same slope, but we needed different y-intercept. So again, any y-intercept that your heart could imagine, as long as that slope is the same, as long as it's still a 2x, I can throw any number that isn't +4 in my B spot. I could do -4. I could do +3.9, right? I could do anything as long as it's not 4. These will never meet. And the last one, an infinite number of solutions. We need same slope, and we also need the same y-intercept. But again, a lot of these times these are disguised. So I technically need it to look like y equals 2x plus 4. But I could sneakily disguise this in a few other ways. I could call it 2y equals 4x plus 8, right? If everything is twice as big, it's still the same equation, right? Or I could move some terms around. I could call it 0 equals 2x minus y plus 4, right? Put it in general form. Move that y to the other side. The same equation, just a different form. So there's one more example here for you. Take a time to pause. See if you can come up with an answer to each of these 3 questions. All right, so I have a few solutions here. The key point is making sure you identify from your original equation, right, the first equation in the system, that you have a slope of 6 and that you have a y-intercept of 3. Right, and then as long as you're following the rules, as long as for one solution in every single case your slope is different, right? We have a slope of 4, we have a slope of -6, we have a slope of 3/4. All of these are possibilities, right? Yours could look different than this. As long as your slope is different, you're set. For B, no solution. Again, you're looking for the same slope. So in all of these, including that last example, these all have the same slope. This one technically has a slope of 6. If I was to reduce everything by 2, right? As long as they have a different y-intercept, as long as our y-intercept never equals +3, then we're good to go with no solution. And for the last one, it has to be the same equation, but you can get creative. In this first one, I've divided everything by 2. In the second one, I multiplied everything by 2 and converted it to general form. And in the third one, I just brought the 3 to the left side. It's none of the forms we've used, but again, the same equation at the end of the day. And when in doubt, try to graph these, right? You can see how many solutions they have. So hopefully that makes sense and you're clear on understanding the number of solutions. We'll be moving on in the next lessons to solving some of these systems algebraically, right? Finding the actual solution without graphing. So work on some of the practice. Email your teacher if you need some support, and we'll see you in the next video.